Can you believe it? Picture a cosmic event so huge that it casts shadows on Earth even in daylight. That's what might happen soon. Betelgeuse, a star in the Orion constellation, is acting strange, suggesting it might explode into a supernova, lighting up our sky like never before. But when will it happen and what will it look like? According to scientists, what secrets might this event reveal? Let's dive deep into what's really going on with Betelgeuse and how it might affect Earth and the whole solar system. Betelgeuse, located around 650 light-years away in Orion, isn't just any star. It's a red supergiant, incredibly bright, over 100,000 times brighter than our Sun. But why does it matter? Well, Betelgeuse is special not only for its brightness but also for its role in human culture. Named after the Arabic Yadala, meaning the hand of Orion, it's been observed for centuries, guiding travelers and captivating stargazers with its reddish glow. Imagine a star so massive it could engulf our solar system. Betelgeuse, at 10 million years old, is much younger than our Sun, but its immense size means it burns through its fuel faster, leading to a shorter life. Now, nearing the end of its life, Betelgeuse is on the brink of a spectacular finale, a supernova explosion releasing unimaginable energy and brilliance. The last time Earth saw such an event was in 1604 with the Kepler supernova, visible even during daylight for weeks. Supernovae like Betelgeuse's are rare events, but their remnants offer valuable insights into the life cycles of massive stars. Betelgeuse's recent behavior has astronomers buzzing. Between October 2019 and early 2023, it underwent a significant dimming, catching the attention of astronomers worldwide. Although it seemed to return to normal by April 2023, subsequent months saw its brightness surge by 50%, sparking discussions about its future. Could we be on the cusp of witnessing one of the universe's most dramatic events? Betelgeuse's unpredictable behavior suggests we might be closer than we think to experiencing its breathtaking explosion. Stay tuned as scientists continue to monitor Betelgeuse, unraveling the mysteries of our cosmic neighborhood. But why the sudden change in brightness? Why did Betelgeuse, one of the most recognized stars in our night sky, suddenly throw a celestial curveball? Stars are not just twinkling dots in our night sky. They are dynamic entities with life cycles, activity, and mysteries of their own. For many celestial bodies, periodic brightness variations can be predicted, much like the rhythms of Earth's seasons. In its stellar lifetime, Betelgeuse has followed a fairly consistent 400-day luminosity cycle. But with the Great Dimming, it seemed to rebel against its own nature, challenging our understanding of the celestial wonders above. Now, you might be wondering, are we on the brink of a stellar revelation? While the exact reasons for Betelgeuse's irregularities are still under investigation, a compelling theory has emerged. This theory, centering around stellar activity and mass ejection, proposes a tantalizing scenario. Imagine Betelgeuse as a giant celestial volcano suddenly erupting and spewing a colossal amount of its matter into space. In past observations from the Hubble Space Telescope, it was revealed that Betelgeuse has previously ejected an enormous amount of its surface material into the cosmos. This ejection, a colossal event, was 400 billion times the mass typically released during similar solar phenomena, equivalent to several times the mass of our moon. Such events can lead to the formation of a dense dust cloud around the star, affecting its apparent brightness and making it temporarily harder to observe. Once this dust began to disperse or was pushed away by the force of the star's radiation pressure, the veil lifted. This could explain its subsequent return to regular brightness levels. Either way, these recent events hint at a star that's not done with its surprises. Many speculate that Betelgeuse might be approaching the twilight of its life, a supernova event. A supernova is a cataclysmic explosion, an astounding burst of energy that can outshine an entire galaxy momentarily. This phenomenon occurs when there is a sudden change in the star's core. Such changes can arise if a star absorbs too much matter from a neighboring star, or in Betelgeuse's case, it could be from the exhaustion of its nuclear fuel, which cascades its mass into the core, setting the stage for a cataclysmic collapse. But what drives a massive star like Betelgeuse to its demise? Born from the gravitational collapse of gas within molecular clouds, Stars like Betelgeuse kickstart their journey by burning hydrogen in their cores. This initial phase, known as the main sequence stage, lasts for millions of years and forms the backbone of a star's life. As stars run low on hydrogen, they evolve, embracing new energy sources. In the case of Betelgeuse, as the hydrogen depletes, it begins to burn helium, leading to the formation of carbon and oxygen. This transition from the main sequence phase to the helium-burning phase is marked by the star's expansion into a red giant. With time, as helium reserves diminish, the star undergoes further expansion and shifts into other burning phases, each characterized by the fusion of progressively heavier elements. The bigger the star, the quicker these transitions occur, given the immense gravitational pressures at play. Then comes the climax, when iron starts forming at the core. Unlike lighter elements, iron doesn't release energy when fused, so the energy produced isn't enough to resist the star's own crushing gravity. The star balloons in size, creating an implosion followed by a massive rebound effect, resulting in the explosive force of a supernova. So, is Betelgeuse on the brink of an explosive end or just biding its time? Recent research by Japan's Tohoku University suggests that the star might be in its carbon-burning phase right now. Lead researcher Hao believes that the core might collapse a few decades after its carbon reserves dry up. However, not all scientists agree. Contrasting studies from Hungary's Konkoly Observatory speculate that Betelgeuse is still in the earlier helium-burning stage. The one thing that scientists do agree on, regardless of these debates, is that Betelgeuse is slated to become the Milky Way's next supernova. Yet, pinning down the timing of this event remains a cosmic guessing game, with bets ranging from mere decades to 100,000 years. Amidst these scientific debates and speculations about Betelgeuse's fate, one fact remains unchallenged: the very nature of our observation. When we look up at the starry expanse, there's a subtle paradox we often overlook. This paradox is rooted in the very nature of time and light in our vast cosmos. Stars and celestial bodies are so distant that their light takes a momentous amount of time to reach our eyes. For instance, the speed of light, while being an astounding 186,000 miles per second, still has its constraints. Consequently, the light from remote stars and galaxies takes its sweet time to traverse the vastness of space before it reaches our sight. Gazing at Betelgeuse, you're actually witnessing a spectacle from 650 years in the past. To put that in perspective, when this very light embarked on its journey toward Earth, the Renaissance was just dawning, and explorers like Marco Polo were making their mark in history. Every observation we make of Betelgeuse is like looking through a cosmic time capsule, granting us insights into a distant past. If, for argument's sake, Betelgeuse had already exploded in a magnificent supernova, we would remain oblivious for another 650 years. So, while we discuss and predict its impending supernova, somewhere out in the vast cosmos, this monumental event might have already unfolded. We're just waiting for it to traverse space and time until it reaches our eager telescopes. The recent revelations around Betelgeuse have led to fervent discussions in the astronomical community, with comparisons being drawn to another sensational discovery from earlier this year, SN 2023X. This recently observed supernova, occurring in a galaxy neighboring the Milky Way, reminded many of the fascinating dynamics and unpredictable nature of the universe. This SN 2023X was unique in its own right, located several million light-years away, showcasing an intense display of brilliance that momentarily outshone its host galaxy. What made it particularly interesting to scientists and casual observers alike was its uncanny resemblance to what many predict will be the fate of Betelgeuse. The spectrum intensity and aftermath of the explosion offered a tantalizing glimpse into the processes that massive stars undergo as they approach the end of their life cycles. For many, SN 2023X served as a preview of what to expect if and when Betelgeuse meets its explosive fate. The connection between these two celestial events underscores a broader theme about the interconnectedness of our universe. Whether it's a neighboring star like Betelgeuse or a distant supernova such as SN 2023X, these cosmic phenomena remind us of the dynamic and evolving nature of space. The realm of space exploration is full of uncharted territories and unsolved mysteries, and nowhere is this more evident than in our understanding of red supergiants like Betelgeuse. As brilliant as they are enigmatic, These celestial giants hide some of the universe's most profound secrets. At a fundamental level, the life cycle of red supergiants, though charted, is punctuated with ambiguities. While we know that these stars evolve from the main sequence phase to their grand supergiant stature, the intermediary processes are less understood. These phases, which might involve tumultuous upheavals in the star's core, are still subjects of intense research and debate. Second, red supergiants are known for shedding massive amounts of material in their later stages. This process is crucial in shaping their evolution and eventual supernova explosions. Yet how they lose this mass, at what rate, and what triggers these outbursts remains unclear. Betelgeuse, with its recent fluctuations, only adds to this prevailing uncertainty. So, what are the implications of a Betelgeuse supernova? At the heart of this cosmic drama, an event of stellar proportions is set to occur. Dr. Stan Maya from Western University suggests that when Betelgeuse does finally explode, it will momentarily be one of the brightest objects in our sky, outshining all other stars and possibly even some planets. For context, even at its vast distance of 650 light-years, the luminosity could rival or even surpass that of the Moon. Night would turn into a pseudo-day for weeks or possibly months. This blinding display would last for weeks, forever changing our perception of the constellation Orion. Following months would see this luminosity fade, and after decades, an outer shell of the once vibrant star would present itself as a planetary nebula surrounding the dim remnants of its core. Astronomers and astrophysicists worldwide are evaluating the potential effects of such a spectacle on Earth. There's some speculation that an explosion could release cosmic rays, high-energy particles that travel through space at nearly the speed of light. These particles would race across space, potentially colliding with interstellar material and ionizing it, leaving a trail of charged particles. When these cosmic rays approach Earth, they could interact with our magnetosphere, producing some gorgeous auroras. But does this mean we're likely to face some serious consequences here on Earth? Thankfully, Betelgeuse is far enough away that these rays would likely be diluted and absorbed by our atmosphere, ensuring minimal impact on our planet's biosphere. While the explosion itself won't pose a direct threat to Earth, the cosmic light show will undoubtedly spark conversations, research, and possibly even concerns. Beyond the tangible and scientific, the explosion would have profound effects on human culture. The sky, observed and revered for millennia, would have changed. This alteration would lead to reflections on impermanence, the vast scales of cosmic time, and our place in the universe. Such cosmic wonders remind us of the ephemerality of existence and our eternal quest to comprehend the great beyond. As astronomers delve deeper into the mysteries surrounding Betelgeuse, they are employing advanced techniques and technologies to monitor its behavior more closely. Telescopes equipped with high-resolution imaging capabilities, such as the Very Large Telescope in Chile and the Atacama Large Millimeter/Submillimeter Array, ALMA, allow scientists to capture detailed observations of the star's surface and surrounding environment. These observations can help reveal changes in temperature, luminosity, and even surface features, offering valuable insights into the star's current state and impending evolution. Recent studies have focused on the star's pulsation patterns, which are indicative of its internal processes. Betelgeuse exhibits irregular pulsations that are thought to be linked to its unstable outer layers. These pulsations can lead to varying brightness levels, further complicating predictions about its future. Understanding the mechanisms driving these pulsations is critical for astrophysicists, as they can provide clues about the physical conditions within the star's core. In addition to studying Betelgeuse's behavior, researchers are also investigating the potential impact of its supernova on nearby celestial bodies. The Milky Way is teeming with stars, many of which could experience gravitational or radiation effects from a nearby supernova event. While Betelgeuse is situated at a safe distance of approximately 650 light-years, its explosion could still influence the formation of new stars and planetary systems in the vicinity. This cosmic interplay of forces highlights the interconnected nature of stellar evolution and the broader dynamics of the galaxy. Another area of interest is the potential for Betelgeuse to contribute to our understanding of nucleosynthesis, the process by which elements are formed within stars. When Betelgeuse goes supernova, It will forge and disperse heavy elements such as gold and platinum into the interstellar medium. These elements will eventually become part of new stars, planets, and potentially even life forms. Thus, the remnants of Betelgeuse will play a crucial role in the cosmic cycle of matter, illustrating how stars are the architects of the universe. Furthermore, the cultural impact of a Betelgeuse supernova cannot be underestimated. Such a monumental event would not only captivate the scientific community but also spark interest among the general public, inspiring a new generation of stargazers and aspiring astronomers. The sight of a brilliantly shining Betelgeuse could reignite humanity's fascination with the cosmos, prompting discussions about our place in the universe and the mysteries that lie beyond. Educational initiatives and public outreach programs would likely emerge in response to the event, aiming to explain the science behind supernovae and their significance in the grand tapestry of cosmic history. Documentaries, articles, and lectures could provide accessible knowledge about stellar life cycles, helping to demystify complex astronomical phenomena. In summary, as we continue to observe and study Betelgeuse, we find ourselves at the intersection of science, culture, and philosophy. Its eventual explosion promises not only to illuminate our night sky, but also to deepen our understanding of the universe, enriching both scientific inquiry and human experience.